let's recap. What is class? We have O and AM, O and AM, O and AM. So oil, natural, air, forced. Similarly, whenever we have a FR3 unit, we have K and AM, K and AM, K and AM. Okay. So whenever we have FR3 oil, we use K as a, instead of oil, we use K. Okay. So that is one thing. We have high voltage, low voltage. So there are two values which is given. Let's say 138,000 volt, 12470 volt, right? So if it's a delta, we don't show any other value because in delta the line and the phase voltage are same. That's why you only see one reading. But whenever you have a star winding, you see two readings like 12.47 by 7600 volt. This represents the line to line voltage. This represents line to phase voltage. So if you make a star winding, this 12.47 kV or 12,470 volts is this voltage, 0.47 kV. Line to line, let's say this is A phase, this is B phase, this is C phase. So between the two lines, and your neutral is here. Okay. So this is line to line voltage. What is the phase voltage? Phase voltage is this voltage. This is the voltage of the phase of that coil. You have a coil here, right? Coil here, coil here. A phase, B phase, C phase coil. So this is the voltage, phase voltage. This phase voltage is actually line voltage divided by root 3 or line voltage by 1.732, okay, by root 3. So if you see this 7200, so this 7200 volt represents this coil of phase voltage of a star winding. This 12470 volts represents the voltage between the two lines. Okay. So these voltages are the working voltages of a transformer. These are known as kV RMS voltage. Okay. And against this, there is a basic insulation level, BIL is given. So let's say 138,000 volts, the BIL of this can be 550, it can be 650. Okay. Depends upon the need of the customer. This 550 and 650 BIL is defined in the IEEE guide. 12.47, the BIL is 110 kV. Okay. This is the basic insulation level. And this is the kV RMS level. Okay. So kV RMS is what? So whenever you have a sine wave like this, these are all sinusoidal waves, right? In the sine wave form. This waves has a different peak at different time. Peak means the amplitude, the value of it. But overall, if you want to see what is the energy, average energy is given, is when you convert this wave to a form of kind of DC wave. You are not converting actually, it is just a representation to show that if this waveform AC, if we compare it with the DC voltage, then we can say that this form of voltage of the AC voltage, 138,000 volts, is actually giving a continuous voltage, average voltage. Okay, so average energy through the system is 138. Okay, but this can have little bit ups and downs in the values. Basic insulation level. Basic insulation level is nothing but it's an impulse level. Impulse is what? When we have a thunder or lightning at the in the sky, and there is a voltage, say your transformer is there, and you have your bushings outside and a line going to a line going to let's say somebody's house or somewhere like that, and there is a thunder. So the lightning strikes. So the voltage which strikes, it travels both ways. It's a high frequency wave. It travels both ways. When it travels, it goes inside the winding, because ultimately these windings are shorted and grounded together. Okay, it goes inside the winding. So what is the level of this transformer which it can withstand is known as the basic insulation level. There are a lot of things comes like insulation coordination and all those, but those are very vast subjects. I am not taking those here. Okay, just for you guys to remember that the basic insulation level, what we talk about, 350 BL, 450 BL, 550 BL, is this impulse level. What we are getting it from lightning surges, okay, which is pretty high. If you see any nameplate, okay. So the nameplate you see, first of all, you have job number, then kVA. We saw kVA also, right? MVA and kVA. So K stands for 1000, M stands for 10 to the power 6. Okay, mega. So this is the power rating of the transformer. Power rating of the transformer remains constant always. Okay, and then high voltage, we have the, I defined it here. Okay, the kVA RMS value. It's a delta winding. Then LP is 25,000 volts here, right? 14.43 kV here for the low voltage. The BIL, basic insulation level, is 450 BL. For the low voltage, it is 150 BL. This was the recap, okay, from the last. I will not go very deep into the concepts of it. I will try to give you some easy concepts or thumb rules to remember. Okay. So we already went through the how the vector diagram works, right? So so vector diagram, like if you see DYN1, DY11, YYD1, YYD11, that we already went through it. Okay, you can see my channel in there. You can find all the lectures.